Okay, so our first one for our bell ringer is determine whether the triangles are similar. If they are similar, write the similarity statement. Find the scale factor of figure B to figure A. So we know figure B to figure A means that the figure B's have to be in the numerator. So you can pick any side to start with. I liked the side that had the right angle. It just felt natural to start here for me. So I did FE. And then that is wedged between a right angle and a 2 congruent mark angle. So the side over here that's wedged between the right angle and the 2 congruent mark angle is DC. So that's the one that goes on the bottom. I'm going to move on. It doesn't matter which side you do next. I just like to go, I don't know, clockwise. So then we have EG. And that's wedged between the 2 congruent marks, the 1 congruent mark, 2 congruent marks, 1 congruent mark. So we have EG, and what was the other one? CB. And then last but not least, it's that base. So we have FG, and it's over B. Yep, DB, BD. And then you could also double check, right angle, 1 congruent mark, 1 congruent mark, right angle. Now we have to substitute in what we know. What we know are those side lengths. I'm going to substitute those in below. If I do that, do you guys think that will be too small? So if I wrote FE is 14, can you see this okay? Yeah. So 14 over DC, which is, okay, our next one is EG. EG is 50 over CB, which is 25. And last but not least, 48 over 24. Okay, I'm going to do some cancellation, so I'm going to change my color. As I do this cancellation, we're going to look at each of these fractions. So what does 14 and 7 have in common? 7. I take 7. I take 14. Take 7 out of 14. How many do I have left? So I have 2 here. 7 out of 1. Oh, I did it again. 7 out of 7? 1. Okay, let's try it on the next one where I don't say the answer. What goes up into both 50 and 25? 25. How many times does 25 go into 50? Twice. How many times does it go into itself? Okay, and then we have 24 and 48. What goes into both of those? Yep, 24 does. How many times does it go into 48? And it goes into 24 once. So we see that they all have the exact same ratio, which is what allows us to say that they are similar. When we have similar triangles, they have congruent angles and proportion sides. So right now we see that that proportion is 2 to 1. So our scale factor here is at 2 to 1 because they all boil down to that. So scale factor, 2 to 1. I also want us to write out the similarity statement. On your quiz, you're going to have to write out the similarity statement. We've read them, but we have never officially written one. So we're going to go back to writing those much like we wrote congruent triangles. So congruent triangles, we began with that triangle sign. And then we are going to go through, and you can write it, the first triangle in any order you like. So I'm going to do F, E, G. You could have written yours in a different order as long as you are making sure the next ones match up. So, I'm sorry? So we see right angle was F, right angle is D. We see that E is 2 congruent marks, C is 2 congruent marks, and then we see that G is 1 congruent mark, and so is B. So those have to match up with their positioning. So the first ones are congruent to the first ones, the middle ones are congruent to the middle ones, and the last ones are congruent to the last ones. Okay, do we have any questions on the first example? Okay, so our second one, we are answering knowing the fact that these two polygons are similar. So we already know that they're similar. Using that fact, what is the measure of angle T? So we have angle T down here. We know that its corresponding angle based on this tells us that's the second letter. So its corresponding angle is L. So we know its measurement is going to be 138. We could have also looked at the picture and decided that. So 138 degrees. Same thing is occurring. We're looking for the measure of angle V. You can look at the picture and see the placement. But we also can go up here. We see V is last and last in that one. And that box tells us what? It's 90 degrees. Okay, the last part here is finding the value of X. So to do this, we have to create one of those ratios, and we have to make sure that our ratio is the proportional sides, and each of those sides have a value to begin with. So we see here, there's no value. We have a 9 here, but we have an X here, so that's ultimately what we're solving for in the question number 4. We have Y here and 16 here, which is what we're solving for, and 5. But this one has both numbers defined as the length. So that's the one I want to use. So I'm going to start with that ratio as 6 over 8. So we have 6 over 8. Those have something in common. What do they have in common? 2. So 2 goes into 6 how many times? Into 8? 4, right? So we see when we did this that the one that's physically on top here is the one we're putting in the numerator, and the one that's physically on bottom is the one we're putting in the denominator. So when I'm trying to find x, we see that that side length here, TU, is proportional to that LM. So this one's going to go on top, and this one's going to go on bottom. So I'm going to have 3 over 4 equals 9 over x. Now that we have this, we're back to our cross multiply and divide. I'm going to switch colors. I'm sorry that I did that in orange so that you can see this a little better. So we end up with 3x equals 4 times 9. 36. We got to get x by ourselves, so we're going to divide by 3. When we divide by 3, x equals 12. Nice job. Our next one, we get to use that same scale factor that we already found, which is at 3 over 4. And now we're looking for y. So y is in the first one, so that means it's going to go on top. So we have y here. And then the side that it is with is that 16. And so 16 goes on bottom. When we do this, now we're going to cross multiply once again. I end up with 3 times 16 equals 4 times y. I'm not a huge fan of multiplying by 16 on Rio. Do you have it?
No, I have a question.
Yes, sir.
Why does 16 go on bottom on this one?
So on this one, 16 goes on bottom because the 8 is where we got the scale factor of 4, and it started on bottom. So whichever one we placed on bottom, whichever shape, it has to stay that way through the whole thing. So you can't flip the order, or you're going to get the reciprocal fraction. So now, I don't like multiplying by 16. If you have a calculator, that's convenient. It is 48. Okay, so we have 48 here. I normally divide the 4 over, take it out of the 16, so then I'd have 4 times 3. But this works well since she had that. Divide by 4. So we see that y equals 12. Nice job. Hey, so any questions on these first groups? Yes, read. So we got 3 over 4 because we looked for two sides that had the answer that were proportional. So we know that this side here corresponds to this side here. And we see that this is a 6 and that's 8, and then we reduced it. Took 2 out of each of them. We got 3 over 4. So that becomes our scale factor.
You got the 2 sides and just reduced it?
Mm-hmm.
Oh, okay.
You could have worked with it as a 6 and an 8. I just don't like to multiply by those, so I always reduce it to the smallest number so I can multiply as much as I can in my head. Okay. I'm writing our objective down. You know the drill. You're writing at the top of your page. Okay, so our objective is to show 2 triangles are similar using AA Similarity Postulate. Okay, when we talked about congruent triangles and we said SSS, ASA, AAS, what did the A stand for? It stood for angle. And once again, that's what it's standing for here. So your next one is going to be the postulate. It's going to tell you what this is.
What is the word after AA?
Oh, sorry. Similarity postulate. I still see a few pencils, so I'll wait a couple more seconds. Okay. So here we see that the AA postulate. If 2 angles of a one triangle are congruent to 2 angles of another triangle, then the 2 triangles are similar. And you see that similarity statement. This makes sense, right? Because the sum of the interior of a triangle is 180. If you know 2 of those, you can subtract it from the 180 and you're going to get that answer. So if the 2 are congruent in both triangles, you subtract those, you're still going to get that third angle. So this is kind of like a shortcut or a quicker method. Go back here. So here we see, well, must these triangles be similar? If so, write that similarity statement. So we see that we have these 2 tick marks. Do you guys remember what these tick marks tell us? Yeah, Ben? Ooh, I think I definitely did. Okay, sorry guys. I'll go back to number 1. Do I have a number 1?
It's just not in order.
That's weird. Sorry about that. Okay, now that we're at number 1, let's begin here. So we see we have 2 angles in each of our triangles. This is side here. That vertex is F. So if you want to add that to yours. We see we have an 80 and a 63 here, but we don't know this one. We see we have an 80 and a 27 here, but we don't know that one. So do we have any congruent angles? We see that B and E are congruent. They have the same amount. But we see the other 2 aren't. So we have to verify that the 2 missing angles aren't going to be congruent. So we can pick either one of these that you would like. I'm going to pick angle C, and we are going to solve for it. How do I solve for angle C? Yep. So we have 180 minus 80 plus 63. So that's basically 100 minus 63. What do we get? 37, my favorite number. So I'll talk about it in a minute. So 37 is this angle. Right now, we know if we did 100 minus 80 would be 180 minus 80 is 100 minus 27 is not going to give me 37. So we know we aren't going to have another congruent angle in here. So we can say these are not similar. So not similar. Not all angles are congruent. And then we use that little congruent symbol to tell you congruent. Okay, so now that we're on number 2, must the triangles be similar? If so, write the similarity statement. So again, I'm going to go back to the same question I began asking you. We're here. What do these little tick marks tell us?
It's congruent.
Means they're congruent sides. And what do we know about the angles opposite of congruent sides? They are congruent. I just changed the slide a bunch again. Give me a second. There we go. So angles opposite of congruent sides are congruent. The same thing is true about sides opposite of congruent angles are congruent. We had those last time. Okay, so when we do that, that means these angles are congruent. So we need to solve for that. So we know the sum of the interior of a triangle is 180. We're going to subtract 36. When you subtract 36, what value do we get? You get 144, which is a nice number. And that's split between those 2 congruent angles. So to split between those 2 congruent angles, we're just going to divide by 2. And that gives me what value? 72. So we see here, this is a 72-degree angle. This is a 72-degree angle. Okay. What do we know about the other one? We have congruent sides, which means the angles opposite of congruent sides are congruent. Yep, we know 72 is in one box. Means 72 is in the other. That means the other one has to be 36. But we didn't even have to go that far. We know that angle S is congruent to angle N. They're both 72 degrees. And we know that angle T is congruent to angle P. And then, since we did it, well, let's write it in there too. Angle R is congruent to angle M. So we know, since we have 2 congruent angles, that we can use that AA postulate, and we can now write that similarity statement. Writing out our angles congruent allows us to do that easy. We already see where they have to match up. So when I do this, I just write straight down STR and PM. So angle or triangle STR is similar to triangle NPM. That's our similarity statement. So by writing it down like that, we've already matched up the angles in the order they're supposed to be. So we're here. You see you have 2 triangles. That's a B. It just got cut off. So we see we have triangle BAC and we have triangle DAE. We want to see if these triangles are similar. So we need to show that 2 angles are congruent. Do we know any angles are congruent? Can you say it one more time? Angle E and angle C. And how did you know they were congruent? Yep, we knew both of them. They were already up on the screen. So they have the same measure. It means they're congruent. We know something else. What else do we know? Looking at that picture, we can tell something else about another angle. What else do we know? Yeah, Randall? What do you know about them? I think you can make an argument about those being congruent, but I need you to tell me more information if you're going to do that. So, yes, it's true, but you have to rely back to these good old parallel lines being cut by a transversal if you wanted to use that one. It's a good one. You just have to be able to remember that first. So can anybody help him on that part? We have a pair of parallel lines that are being cut by a transversal. What are these angles called? Yep. They'd be corresponding angles. So because they're corresponding angles, we can tell you that. So we have angle D is congruent to angle B. I'm going to write core angles, just so I know. Now I'm able to use that postulate. So I can now use AA Post. And then they want us to write that similarity statement. So we see that triangle. I'm going to do the big one first. We see that BAC is similar to the angle that is congruent to angle B is angle D. So then we have triangle DAE. And those all correspond to the congruent angles, the way they line up. The other one to see here, yeah, Nemo?
Is this like the proof of statement? Do we have to put specific?
So here, on this case, I would want you to tell me this. For similarity, yeah, you're going to have to do this statement. Is that what you're asking?
Not just specifically that, but like, do we have to put specific stuff like
How I'm solving it up here is what I expect you to do in your
Let's
test.
say AA what?
Postulate. I just didn't want to write out the whole word. So when I did this with my other classes, the other angle we found, we didn't see what Randall saw. That's true. He used the fact that we knew they're parallel. We knew they're parallel by the fact that they had arrows. But you see that angle A is in both triangles, and therefore it is congruent to itself. So angle A is in the big triangle. Angle A is in the small triangle. I could have said angle A is congruent to angle A, and we would have been done. Both of those work. It was a really nice way of doing it. Any questions on this one again? Anybody else? Anybody still writing? Awesome. 27, it was given in the problem. I just had to add it because it wasn't on the page.
Have you ever tried to like write this in 5 minutes?
Yes. Okay, we have 15 minutes, but we definitely will be able to. Okay, so here we have seen this bow tie shape before. We know something about the angles. What do we know about these two angles? They're the same by what? Vertical angles. So by vertical angles, we know this has to be at 41 degrees. Okay? I need to solve for one of the other angles, B or E. Do you want to do B? Okay. So to solve for angle B, how do I do it? Yep, add them together, subtract from 180. So 56 plus 41. What value do we get? I think you need to rethink your math real quick. Try it again.
41 plus 56.
Oh, you just did that part. Okay. I thought you did the subtraction already. I was looking for the final answer. I apologize. So for the final answer, what'd you get?
83.
It's going to be 83. So we're at 83 degrees here. Okay. What do we see? So we see here we have an 83 degrees. Oh, that's a lie. Erase it. That's that middle angle that we did the vertical angles with. So that's 41. Angle B is the one we just solved for. You guys just told me that is 83. So right now we know two angles are congruent, which means that these are similar triangles. So I could go through the fact of going here, taking 180, subtracting, but I know what I'm going to get. I already have two congruent angles. That means my other angle has to be congruent. So you just told me it, Rio. What was it?
56.
We know it's going to be 56. We got that from vertical angles. A, C, B, since we had that.
So what was the point of us doing all that math if the answer was right at the bottom? On the problem it said 83.
Oh, this part told you 83 degrees. We had to find this one to verify that they were congruent. So you had to do the math to show that the two angles were congruent. Nemo?
So if you were supposed to say you had to do a similarity statement, would you say the reason why like A?
Okay, that is literally our next part, so give me a second. So triangle.
Huh?
The similarity statement's what's coming next. So.
Okay, so I was about to ask you, so like, the reason why A and E are the same, would it because like they like interior or like interior corresponding? Because I remember you put corresponding angles on top.
So the last one worked with corresponding angles because they were parallel lines cut by a transversal. This one we will only use. I'm not sure if I'm understanding the question you're asking. So I feel like I keep answering the same question.
It's like a question basically based off of the problem.
Based off of this problem.
The one before.
Okay. Give me a second. I'll come over and I'll look at it so I can see exactly what you're talking about. Okay, so here, do you want to write this similarity statement? You're good? Okay. So we have ACB is similar to triangle. A had the 56 degrees. E has the 56 degrees up here. So that has to go first. So E, C's in the middle. It's congruent to C. And then we have 83 degrees is B, which means that D is that one. Rio, did you say you had a question? Oh, I thought I heard you. Okay, now that we have this, we have to find the missing side length. Once again, we have to create that ratio. We have to look to see. Right now, we're looking for CD. CD is wedged between 41 and 83. So if I'm looking for CD, which other side is wedged between 41 and 83? Which one is it? What'd you say? BC. And now we have to relate it to the two sides that are proportional that we have the information about. We see that happens with the sides directly opposite of the 41s. So the ones between the 56 and the 83. So my CD is on top, which comes from this triangle, CD. So that means that ED has to be on top on this side. And that means on the other side, it has to be AB on the denominator. Now we're going to substitute in what we know. We don't know CD. We know that BC is what value? We know that ED is. And we know that the side that I'm missing, AB, is 8. We're going to cross multiply. So now I get 8 CD equals, I'm just going to multiply that out already, 120. We've got to isolate CD because that's the distance we're looking for. So I'm going to divide by 8. If you do not have a calculator, I start by reducing by 2. I see that it goes into this 60 times, goes into this 40. Let me go to my next color. We can take out, what'd you say? Okay, we can take out another 2. We're at 30. 2, and then we see that's just going to be 15. So we see that CD equals 15. Any questions on this one? So our next one, it doesn't say, it doesn't already tell us that. It tells us is. So we're asking that question, are they similar again? We're in that same position. We have to show that we have two congruent angles. You have, we have two options, right? We can solve here, find this angle. We'd have one here, but we'd still have to find one in here. I think it's easier to start solving this one. So we are going to take 180 minus 90 gives me what? It has to be a split between those because angles, opposite congruent angles are congruent. So Rio's correct. It is 45 degrees. What do we notice? We do. So we now see we have two pairs of congruent angles between the two triangles, which then leads us to saying, are these congruent? So let's write that congruent statement. So we can do X, Y, Z. I said congruent, I'm sorry, similar. Is similar to triangle. X, so that corresponds with R. T, nope. Y goes with T and then S. So it's the same as what the top says. So yes, that is true. And then the bottom part is writing out all those proportions. Do you guys want like 30 seconds to write those out by yourself? No, so let's do it together real quick. Oh. Okay, so let's start over here. I like to do the base first, so X, Y. Which one's the one wedged between those two 45 degrees? RT. Equals, and then I'm just going to go up, XZ. And that's going to be the over RS. We see ZY is over ST. Okay, and then I wrote all my angles that are congruent. So I did angle X is congruent to angle R. Angle Z is congruent to angle S. And angle Y is congruent to angle T. Oh, I didn't mean to get rid of it. Sorry.